Question 11.3. Draw the structure of the isomer of C6H10N2 that contains two primary amine groups. So what's a primary amine group? Primary amine means that the N is bonded to one carbon only. A nitrogen has 3 bonds, so the other 2 bonds must be H's. So it must be NH2 and a carbon. And it's got 2 of these NH2 groups on there, and yet it's only got 2 peaks in its carbon-13 NMR spectrum, even though it's got 6 carbons. That gives you a clue. It would only do that if it's symmetrical, because the atoms, the carbons on one side, will be in the same carbon environment as the ones on the other side. Because if it's symmetrical, then you get carbons in the same environment because they're bonded to the same atoms. Now, if it's a very, very long chain, the ones in the middle would be different environments to the ones towards the end. So it's quite a short chain that's symmetrical with 2 NH2 groups. Now, a little bit of trial and error will bring you to this then. It's just 2 carbons long with 2 NH2s, 2 primary amine groups, and 4 methyl groups, and perfectly symmetrical. If it was a very long chain, then the ones in the middle would be different, have different carbon environments. Every time you moved along a carbon, it would have a different environment to the ones towards the end. So it's got to be quite a short chain, and those 4 methyl groups then have 1 peak, and then the 2 carbons in the middle are in the same environment, have a second peak with 2 amine groups, primary amine groups. Draw the structure of the isomer of C6H10N2 that contains 2 tertiary amine groups. Now, a tertiary amine group has a nitrogen bonded to 3 carbons and only 2 peaks in its carbon-13 NMR spectrum. So again, it's quite small, and it's going to be symmetrical. And so by sort of a little bit of trial and error, you should be able to work out it looks a little bit like this. A nitrogen with 3 carbons around it, 2 methyl groups, another carbon, 2 methyl groups, another carbon, and then the 2 carbons bond. A tertiary amine, 3 carbons around it, quite a short chain, symmetrical, so each of the methyl groups are in the same environment, a 1 peak on the NMR spectrum, and those 2 CH2 groups are in the same environment as well and produce a second peak in the carbon-13 NMR spectrum.